Hello, everyone, and welcome to the Switch Statement Podcast. It's a podcast for investigations into miscellaneous tech topics.
This is episode 1 in our series on Refactoring, the iconic book by Martin Fowler. Hey, Matt.
Hey, John. How are you doing?
Oh, I am doing fantastic.
Thank you. I am doing well myself. Excited to start a new chapter, no pun intended, of Switch Statements. Well,
yes,
potentially
so we're doing book reviews.
Yes, doing book reviews.
And we've chosen a lovely little book, or a big book, I guess, called Refactoring, Improving the Design of Existing Code.
I feel
Something
like
that we
this
should all be trying to do.
I feel like this is a book that has a decent bit of a reputation. I don't think it goes quite as far as to be in the kind of echelon of design patterns per se by the Gang 4, but
yeah, it's in the library at Google, and you see it on bookshelves of prominent engineers.
Right. So we want to be those prominent engineers one day.
Yeah,
so.
we're aspiring to that, so we're reading the book.
Right. I wonder if it makes sense to talk a little bit about the book in the abstract. At the high level, like, why would you want to read this book?
Yeah, I mean, actually, it's interesting because I don't know that much about this book. I've definitely heard about this book. I do know a lot about refactoring. Refactoring is just changing the code without changing the behavior of the code.
Right.
And the reason you want to do it is so that the code's easier to modify, easier to read, easier for maybe newer engineers on your team to understand. So it all has to do with creating a efficient team that can perform at a high level against the same code base.
Yeah. And this is something that he goes, and I'm jumping ahead a little bit, but he gets into in chapter 1. But he said the test of good code is how easy it is to change. And I feel like that's a really good heuristic. Like, refactoring should make it easier to change the code in the ways that you expect to need to in the future.
Yes.
So.
That was well put. He has a quote on the cover: "Any fool can write code that a computer can understand. Good programmers write code that humans can understand."
Wow, very deep.
All right, well, let's hop in. Chapter 1. What did you think? What did you think of chapter 1?
Just to explain, chapter 1, he walks through an example, right? He says, okay, before we talk high-minded about refactoring in the abstract, let's just give an example. So I thought there were some pretty surprising things that he did when he was going through the book. I want to say
Yes.
the first thing or the thing that really made me scratch my head is there's a point at which he says, take out of the local variable. Like, you're only using this in 3 different places, so just inline the call that you're assigning to that local variable into the, inline those calls in all the different places, which just sounded like completely insane to me. Like, why would you ever do that? And I think
this was the time where he basically replaced occurrences of a local variable with like a lookup into a map, right?
Yeah, exactly.
Yeah. It's funny because there were several points in this first chapter where he mentioned a philosophy, like removing local variables, which I am a huge proponent of. I think local variables are actually one of the top sources of bugs. Like, if I had to just guess my top 10 list, that would definitely be on there. But the way that he did it in the book was just weird to me. Like, it was like, what? I just haven't seen that type of thing before.
I think sometimes, and I can fall victim to this, where just to structure the code a little better, you pull out this multi-step thing into a couple of local variables that you're only using one time. But it's kind of just to be explicit, like, okay, this is what this thing is. It just breaks down the parsing to be like a little bit simpler. So you don't have these like very beefy like computations inside of like a parameter to a function or like an argument to a function, excuse me. So,
yeah, exactly. So I don't know. In that particular case, I think it was like he had a plays dictionary, and he just replaced every occurrence of this local play variable with like a lookup into the plays dictionary.
Yes.
And I might have kept that local variable if I was writing this code.
And so the example is some business has purchased some amount of tickets for its employees to a play or something, and then you need to calculate how much it costs, and then what kind of bulk discount they might have, and then at the end kind of format that into some bill or what have you. It's interesting. The other thing that I will say is, this can maybe sound like braggadocious, but like I kind of, when I was reading the initial example, I kind of immediately jumped to like what wound up being the final refactoring.
I don't think that's braggadocious. I would hope that a lot of engineers who have kind of an object-oriented background would immediately jump to that end, because I thought that was one weird thing about the chapter is he did a bunch of small kind of micro refactors, and then at the end it wound up being like what should have been the kind of this first big step, like, because when you're refactoring code you kind of need to take that big step back and ask yourself the question, like, you know, do I need to just kind of redesign how this works completely? And he and I see why he did it, and I kind of appreciate why he did it. He did this example with a bunch of little tiny examples leading up to this good outcome. But I think in practice, a typical engineer would just kind of take that big step.
Well, I think this is kind of the thesis of the book, is that actually you shouldn't do that.
He says many times, just take the micro steps. Which this is one thing I wanted to chat with you about, like if we agree with that, if you agree with it.
Well, this is a really interesting point, because I think I just start doing this like massive refactoring like right from the beginning, and I'm like changing, and it takes me like an hour until I'm back to like, you know, compiling code again. And like I think that's wrong. Like I don't think that's the right way to do it. And so I'm thinking maybe I should use it as an exercise to be like, okay, let's try to take the Martin Fowler approach, go like super micro steps. And because like what it almost feels like is, and maybe this lends credence to like when they're saying refactoring, it's like, you know, if you think about breaking a number down into its factors, like let's say your code right now, like the program is 56, but like the code that goes into it is 7 and 8. And then what it feels like he's doing is like, okay, I'm going to break this down into 7, 2, 2, 2, you know, and then from those like atomic parts, I'm actually going to like recombine them in a way that makes sense, as opposed to just trying to immediately jump to like, it's like you're immediately jumping to 7, 4, and 2 without going to 7, 2, 2, 2 in the interim.
Which I think he did for the purposes of writing. And I also do think this is good philosophy. Like this, the smaller your changes can be, the better. And I try to adhere to that. It's hard. It's hard to adhere to that because you want to kind of do something meaningful, and sometimes a small change doesn't feel meaningful. But I do think it's a great philosophy.
This is interesting because like I kind of disagree. I don't think he was doing it for the purposes of illustration. Like I think he really believes that like this is the way that he should have done it, even when if he was doing it live.
I just got the sense. Well, and I think that all the principles he mentioned are things that he actually adheres to in the real world, and I think everyone should probably. But I think that the example was just tiny and contrived, and it's just hard to apply like real world examples or real world principles to such a tiny contrived example. And I was trying to ignore that, I guess. Because I just think in this particular case, like to use these principles against against 40 lines of code just felt super weird. I agree. I think he probably does use these principles in real life, and I think they're good principles.
There's a part where he says, sometimes, you know, I don't do the compile test commit loop. Yeah. And then I get bitten, and then I go back to doing the compile test loops. I think while in practice, I think you're right. He's probably combining a few of these steps. And again, like, it's kind of hard to divorce the simplicity of the example, because I think in this case, even doing the quote unquote big refactor is actually still a very small change overall.
Right.
But I do think he would recommend trying to take like these very small kind of atomic steps, where everything remains like functional along the way.
Yeah, I was wondering if there was a reason he sort of delayed the object-oriented thing until the very end. Because I think object-oriented programming can sometimes lead you to these situations where you need to refactor. Whereas when everything is just these tiny little functions that operate on data, stuff just is already broken down into its like constituent parts.
Well, this is a kind of an interesting part, because like maybe you say like, oh, the best way to structure this system is actually just to have everything, just to have 7222, and just like to leave it all in these like very tiny components without making assumptions about how they need to be combined.
Yeah, I mean, I think a lot of people would make that argument. That's kind of like the C argument, functions that operate on data. Which is a strong argument. I mean, it's a debate that rages on.
I thought one part that he says where he talks about saying like he read this code, and then like there are understandings that he has gleaned from reading the code, and what he wants to do is put those understandings about the way the code is working into the code itself, which I thought was like a super important point, and something that I really try to think about when I'm programming is like, we want this to be as explicit as possible.
I feel like in my professional life, I've strived, and in recent years, I think when I started out, I wasn't doing this, but like these days, I strive to write code that like a caveman would hopefully understand.
Oh yeah.
And I think that is the mark of a good programmer, especially if you're working in like a big, professional environment. One of my favorite parts of the chapter was this Ward Cunningham quote. And it's exactly what you're saying. He just mentioned how the brain is the most volatile form of storage. So he tries to like take it out of the brain and put it into the actual code itself.
Oh yeah, that is very true. This is something like, what is it? Getting Things Done. I don't know who the guy is, but it's the same thing. Where it's like your brain is not a good information storage mechanism.
Exactly. Yeah.
There was one question I wanted to ask you about. He says, if the code is not structured well, refactor it first, and then add the feature that you're trying to add. I'm curious, what did you think about that?
I'm super glad you brought that up. I think it's probably true that maybe you should do that. Does that happen in the real world? Like in a professional environment? Very rarely.
Yeah.
I would say. And that's why you get into these cases where, some system architecture just gets completely out of hand, just totally weighed down by tech debt. Because maybe people aren't making this decision. Yeah. So it's super thought-provoking, little sentence.
It's interesting because, like, I wonder if, like, in the limit, this actually isn't that expensive to do. Like, if everyone is doing it all the time, then, like, and assuming everyone is like agreeing, because I guess you could wind up with two people refactoring like back and forth forever. It's like, one person refactors the system, adds a feature, the other person refactors the system, adds a feature. So hopefully there's some like agreement on the team about what the right kind of design philosophies are. But I don't know. Maybe in the limit, like it's something that you look at one specific instance and you say, well, I have a feature that has a deadline. We're going to announce this to customers like in the next quarter. So like I can't yes, there's ways that I wish the code were structured differently. But this is like I don't have time to kind of restructure all this code because I don't know what unintended side effects there are going to be and all that other stuff. And I mean, that's obviously, that hopefully is mitigated by good test coverage. But
right. It's also it's famously difficult to sell that type of project to your organization because it's like, does it take a bunch of work? Yes. Does it earn any money? No. Like what benefit does it confer? Well, the code is better. Maybe...
I think the argument needs to be that like if the features are being shipped faster, like everybody wins.
Yeah, but that's hard to prove. It's just you're talking about developer velocity, which is like one of the most notoriously difficult things to measure. A theme of this chapter for me was like he would mention a principle that I totally agree with and I think is a really good principle that engineers should, take to heart. But then he would like give an example and I would be like, I would just kind of feel uncomfortable about the example. Like one thing, he talked about variable naming, which I think is, one of the most important things to get right. But then he started talking about this weird naming pattern that he does where you like, if you have a performance variable, you call it like a performance, which is cool. I guess I can't even remember the logic behind why he did that. I don't know if you'd have like a performance and then the performance or something, if something was a singleton. But anyway, I just thought it was this interesting case where he was like, I'm making this variable as clear as possible by calling it a performance. But like, I see that as like a tribal thing. Like, yeah, your tribe might name variables a performance, but like, I've never seen that before. And it's weird to me. Like I would be looking for like B performance if I was reading that code. Like, where's B and C performance?
Yeah.
Obviously a super tiny thing. I thought it exemplified that theme of like, he's listing off these great principles, but then giving these examples that almost like undermine it to me.
I was not impressed with his naming. Like, I kind of hated the way he named everything. Like, this is what's funny is like, I am kind of the opinion that functions should be verbs. And like, he never does that. Like, all of his functions are nouns pretty much. Like, if I recall correctly, or that's not true. Some of them, like there's one like enrich performance.
Enrich. I was like, why would you ever call a function enrich? Like you're talking about being as explicit as possible. Like enrich is completely meaningless.
Yeah,
like it's just adding some random additional data to the.
You give no information about what this thing is doing.
Yeah, are you like passing uranium into this function? Like, no, you're passing a play into it. Like, what's happening here?
Yeah,
I just thought that was weird. But yeah, I agree. And he also does the thing that, and this is just totally a pet peeve and almost not even worth mentioning, but like, he'll do the thing where the function name, like, includes the kind of variables. Like, it'll be like amount for, and then like the variable is play.
Oh, interesting.
Which, honestly, I sometimes don't mind, but I also sometimes just think it's a weird way to do things. Like, I think the function should just have the name. But yeah, he did that too.
Yeah.
There was one other thing I wanted to chat about. I thought this was kind of an interesting philosophical thing. There was a sentence, and I should have wrote down more context in my notes here because I don't really remember, but he said, at that size, a single inline function is hard to understand. And when he says at that size, he meant like, if you have this massive code base. And he's saying a single inline function is hard to understand. And I just thought that was like, it's one of those sweeping generalizations that's meant to say like always refactor things out into like individual functions. But I actually sometimes believe the reverse of this. I think sometimes when you refactor things into an individual function, it might be okay at first, but like, is that function well named? Does someone come in later and edit that function and make it like slightly murkier, based on the name and what it's actually doing? Whereas if the code is just in line and you see the code, like it just is what it is. There's never this case where you're reading a function name and sort of assuming what it's doing. So I don't know. There's a thing that a lot of these engineering books do where they have these sweeping generalizations, and I can almost always immediately think of like exceptions to these rules. And I was just curious what you thought of this.
Yeah, like I think it's always important to think in terms of like these are heuristics, right? It's not like it's I agree. Like any of these laws, there's going to be exception or like laws. Any of these things that they're saying, like there are going to be exceptions to the rule, and like being a really good programmer is knowing when to avoid an unnecessarily stringent adherence to some approach. I'm actually reading the code again. I just wanted to understand what he means by a single inline function. Like, is he saying like, yeah, I guess I'm confused. Like, what?
Yeah, I definitely should have written down more context. I think he had some code that was like somewhat repetitive. Like he was calculating the cash amount that a play earns, and he created a function for it. Which in the case that he did it, I totally think is fine. It was mainly just the statement itself that I wanted to discuss.
I guess is his point like if you do the operation of inlining a function, like it's hard to understand like the ramifications of that, or like what is an inline function in this context, or is inline function a verb or a noun?
I guess I took this to mean if there's some part of the code that could be composed into a function, you should. That's kind of how I was understanding this, and maybe, I don't know, I might have missed some nuance.
Yeah, it's interesting because like when I'm reading this, I basically take this to mean like, oh, if I made this example 200 lines long, like it's going to be much harder for you to reason about the modification that I'm making here in this example. But I didn't take it as like a larger suggestion.
Maybe I like misunderstood his point, but I've definitely heard that before where, people like to aggressively factor things that could be functions into functions. And, I think a lot of times it can be good. Shorter code is easier to read. And if a function is well named and does exactly what you would expect it to do, then it's much better to just read the name of a function as opposed to like, 6 lines of code or something. But there just are cases, and I've even seen this in practice where that completely falls over and actually causes much worse errors than to have code in a function. And it's something that happens over time generally, where someone will edit that function later and not rename it. And he even discusses this, where he says if you're changing a function, you should like strongly consider renaming it, which I agree with.
This is interesting because like, and it's a fundamental problem because like there's always going to be potential ambiguity in the name of the function, because like there's not going to be one perfect way to name a function such that like the contract is perfectly clear.
Exactly. And I think that's the crux of the issue is like whenever you're taking a bunch of code and putting it into a function, you're taking like a white box and turning it into a black box. And yes, you may be able to name that black box perfectly and a user can understand, what the white box would be, but that's what's happening. I mean, you're taking something and kind of hiding it. And I've just seen that go the wrong way, I guess. There was just one other tiny thing I wanted to mention that I thought was funny. There was a point where he refactored the code a bunch and he was like, okay, it was 40 lines. Now it's 75 lines or something. But that's okay because it's so much easier to understand. And I just thought to myself, like, I think there's cases, that's almost a doubling of the number of lines. And while I would usually agree that, like, even if it's more lines of code, if it's like better designed, it's better. It was just a significant amount of extra code. And I just thought it was interesting.
Yeah, don't get me wrong. I love deleting unnecessary code. Like, less code is better, in my opinion. But I'm not a like number of lines purist. I also wouldn't say I try to optimize for minimal code. Like, I definitely don't want unnecessary code. But as long as I feel like the structure it makes sense and is understandable and all that stuff, like I feel like maybe it's a proxy for being like, let me take a step back and just see if there's like some unnecessary structure here. Because, like, I think I see what you're saying. Like, it could be its own problem. Like, maybe it's a smell that you've added too much boilerplate, and like there's a simpler way to get the same effect. But like, I don't think it's a problem in itself that you've doubled the lines of code.
Yeah, I guess it's not exactly what I'm saying. I think like he mentioned this doubling of the lines of code and just kind of like immediately moved on. And I thought it was worth a little bit more consideration. Like, for instance, if engineers were to come to me and say like, oh, we want to, rewrite this system that's currently, these 3 services, and we're going to turn it into like 9 services, but it'll be like way easier for everyone to understand. I would kind of be like, wait a second, like let's take a deeper look at this. And, I don't know. Because I agree, like, lines of code is completely meaningless. You can have something that's very short but impossible to understand. But I do think it's something to consider. I mean, it is a data point in the kind of analysis of system complexity. Like, literally, how many raw lines of code are engineers going to have to read?
Right.
And so, something to consider.
He made a similar point about performance and was basically like, just don't worry about it. Like, just refactor away and then worry about it on the other side. And and again, like, I think I had a very similar feeling to what you said, where it's like, it was a little bit too like
cavalier,
like performance.
Yeah,
that's a problem for after the refactor, and like, I don't know that I 100% agree with that.
Yeah, I mean, and he should have just mentioned like depends on what you're working on, Like if you're working on a server that's serving, 10 million requests per second or something, then maybe this is important. But generally speaking, maybe it's not.
I think, and again, maybe this goes back to what we were saying before, where every rule has its exceptions. But there was a lot that he said that I agreed with, where it's like, this may not be the critical path, and so spending a bunch of time optimizing by not doing 3 calls into a map, which I agree, it's like, yeah, that's probably not going to slow down the code in any perceivable way. I think it was a little bit too like, don't worry about it in that case.
Right. Yeah, I think that's actually a good way of putting it. Because, I think he knows these things that we're talking about. But I think he was just trying to keep it simple, maybe.
Yeah.
And it's almost like he almost kept it too simple, maybe. But, he's going to dive deeper into all these things.
Right.
If I could, like, sum up my feelings about the chapter, like, I'm actually really excited about this book. There's a lot that I thought was, like, almost silly about chapter 1. But all the principles you mentioned I thought were good. Just kind of the example that I thought was kind of weird. So I'm pretty excited about moving forward in this.
Yeah, no, I think it's going to be good, and we had talked before this, and I think it's just going to be useful to have just a language handles for these things that you're already familiar with, but it's just like, okay, this has a very concrete handle. It's called split phase or what have you, and which I thought was a cool thing, and it's like something I've obviously done before.
What is split phase?
So, and actually, let me know if this is correct. So, as we described, the example program is used for calculating a bill and then printing it. And in the original function, like, they were doing that all together, and like they were just printing it as text.
And the original feature request was to print it as HTML, right?
Right. Yeah, they were like, we want to be able to print it as either text or HTML. And so the splitting of the phases was breaking it down into, okay, well, phase 1 is to actually compute the data required for the bill, and then phase 2 was to print it, which you can kind of like modularize, where it's like, okay, well, we have the HTML printer or we have the text printer. So anyway, so that's split phase. But anyway, but this is a perfect example where, having this handle on, you should just like, and I'm probably not going to say this to my coworkers, like, this looks like the job for split phase, if you know what I mean.
Yeah.
But I think it'll be useful to kind of frame my thinking.
Yeah.
But no, I agree. I'm super excited, and yeah, I can't wait to see what he has next. And then the one tiniest little last thing, I just thought it was hilarious. There's a point in the refactoring where he's like, we want to make this function called XYZ, but we already have an XYZ, so I'm going to call it applesauce. Just so I can name it something random, and then I'll think of a better name later.
Right. Yeah, it's like, just don't commit that.
Yeah, well, that's the name of the game. It's like, okay, well, you need to kind of keep that to do in your head. Otherwise, lest your coworkers think you're some insane human being.
Yeah, that was hilarious. All right, well, cool. Yeah, I'm looking forward to chapter 2 next time.
Yeah. Chapter 1 in the bag. Yeah, me too. So, see you next time.
See you next time.